Hello Blue Planeteers, welcome back to week 10 of the Hydrosphere module. This week and next week we'll be exploring my favourite topic, the oceans. So to give you a brief overview of what we'll be doing this week, in lecture 1 I'll be introducing you to the ocean. We'll be taking a quick look at its origin and structure, how we divide the ocean into the surface and deep ocean, and why we do that, how science goes about measuring the ocean, and we'll deal quickly with why the ocean is salty and what determines variation in the saltiness of the ocean. In lecture 2, we'll talk about wind-driven circulation of the surface ocean, and in particular take a close look at the surface currents and how wind and vorticity combine to drive currents and upwelling. In the tutorial, we'll explore ocean surface and deep currents, and in the practical, we'll explore density-driven flows. Our learning objectives for week 10 are set out here, and I won't go through those, but leave you to read through them yourselves. So why should we care about the oceans? Some of us just enjoy it. Others may be just simply indifferent. But I presume because you're taking this course, then maybe there are other things that you consider to be important. So take a minute to consider 2 things you consider to be important about the ocean, and 2 important scientific questions you might have about the ocean. Here's a few that I've come up with. The importance of the ocean for food supply. Over 1 billion people are reliant on the oceans as their primary source of protein. There are lots of questions around how the ocean will continue to be able to support those people in their basic food needs. The importance of the ocean to global warming. We know already that the oceans have accumulated at least 90% of the excess heat due to anthropogenic global warming. The heat that gets transferred into the ocean reduces warming of the atmosphere and the land, and the rate at which ocean heat uptake controls the pace at which global warming occurs. So the little diagram on the left here shows you that almost 93.4% of global warming, the excess heat accumulated by the planet due to anthropogenic greenhouse gas emissions, has been taken up by the ocean. Only 2.3% of that heat is actually in the atmosphere itself. Other parts of that heat are contributing to the melting of glaciers and ice caps, sea ice, and warming up the continents. That excess heat uptake by the ocean is manifested warming of the surface ocean, which is the blue curve here, over the last 60 years. And you can see that ocean heat content is increasing rapidly in both the upper 100 metres of the ocean, that's the surface ocean, or the upper 700 metres, where there's even greater heat uptake. So that heat uptake is actually reducing the temperature in the atmosphere. The ocean is also important for taking up greenhouse gases. The oceans hold the largest stock of carbon amongst Earth's surface spheres, so we learnt this last week. 40,000 gigatons of carbon are held in the ocean versus only 800 gigatons in the atmosphere. So there's more than 50 times the amount of carbon in the ocean than there is in the atmosphere. Future carbon dioxide uptake by the ocean and its exchange with the atmosphere is vital to predicting the fate of greenhouse gas concentrations in the atmosphere and the course of future climate change. The red arrows indicate the uptake of CO2 in the surface ocean. That CO2 reacts with water to produce carbonic acid, and that makes the ocean more acidic, as indicated by the hydrogen ions here, and it also produces bicarbonate ions. And we'll be discussing this more, particularly in week 11. So you have end up with a much better understanding of this process and why it's so important. So the things that actually happen in the ocean really determine how fast that anthropogenic CO2 is taken up by the ocean. And a lot of processes also determine the exchange of CO2 between the atmosphere and the ocean. It's very, very dependent on the productivity of the ocean and the upwelling of cold, carbon dioxide-rich water from depth into the surface ocean. This diagram here shows where carbon dioxide is being taken up by the ocean. You can see the northern parts of the North Atlantic here. There's very strong uptake of carbon dioxide. And also along this mid-latitude belt here through the Southern Ocean below Australia. So these are areas of the ocean where there's strong uptake of carbon dioxide from the atmosphere. So in addition to that, some of the big questions we'll be discussing this week and next week. Where did the water in the ocean come from? Why is the ocean salty? What causes ocean currents? What determines and controls the amount of primary production, that's phytoplankton growth, in the ocean? And to what extent will the oceans continue to absorb excess heat from global warming, and that heat relative to the atmosphere and the ice sheets? How much CO2 can the oceans absorb? Could ocean warming cause the ocean to become a source of CO2? Could we enhance ocean uptake of CO2 to reduce atmospheric CO2 levels?